Hello, this is question 9 from the 2019 winter set of exams put on by Cambridge International Education. This is paper 1-2. This is a 4-part question about a quadratic curve and a straight line. And the straight line is missing a value there. We can see it's 2x minus k. So when we play around with k, we'll get lots of different answers. You can find a link to the image of the question in the description below, and I do recommend you try the question first. I've wrote down the two equations they give us, fx and gx, and part 1 asks us to find the value of k for which the line y is equal to gx is a tangent to the curve y is equal to fx. So I'll do this two different ways. Well, I'll do it one way, but then I'll show you a second way. The second way is the way I tried to do when I first thought of it. Then I realized halfway through, wait, there's an easier way. So I think I'll show you the easier way first. And to do that, we need to sort of have a little understanding of what these two things look like, what y equals fx looks like. Y equals fx is a quadratic equation, a positive one. The x squared is positive. So it will look something like this. That's all the detail I really need. I don't need much more than that. And then this line here, this is infinite different lines, because if we change this number, there's infinite different lines. But the 2x tells me that we have a positive slope, something that looks like this. But for example, it could be this line. If we change k, we get infinite of these lines here. Now the question asked us about a line, one of these infinite lines here, that is a tangent to this. So let me draw that in. Something like that. It was meant to touch it just once, and the curve should maybe go up a little more. So this is roughly what this looks like, this question they're asking us looks like. And now that should give you an idea. They intersect. When these two curves intersect, let me rub out these other lines that we don't need. And when these two curves intersect, that means that 2x squared plus 8x plus 1 equals 2x minus k. Now we've done questions like this many times where we solve two things intersecting, we get multiple answers. And in fact, if we tried to solve this, well, one, we wouldn't be able to, we don't know k. But if we knew k, there's three things that can happen. We could get 0 answers, we could get 1 answer, or we could get 2 answers. Now they've already told us it's a tangent. It's the example where we only get 1 answer. Well, let's begin to solve this, and hopefully you'll see what I mean. 2x squared and 2x take away is plus 6x and plus 1 and then plus k equals 0. So this is a quadratic, and from our image, from our knowledge of our understanding of drawing these equations, we know this only has 1 answer. That means I do not have to solve this question. I have to solve a different question. I have to solve the question b squared minus 4ac equals 0. This is the b squared minus 4ac from the quadratic equation, that thing that's in the square root usually. And we know that equals 0 because there's only 1 answer. When this is bigger than 0, we get 2 answers. When this is less than 0, we get no real answers. So we need to solve this question here. Let me do it up here. B is 6, so we get 6 squared. And minus 4, A is 2, and C is 1 plus k. And all that equals 0. We can just multiply most of this out. We get 36 minus 8 minus 8k equals 0. Let's make the k positive. So we get 8k, move it over here, and then I'll switch it in my head, I guess. Leave these two guys on their own side. So they are 36 minus 8 is 28. So k is equal 28 over 8, which is equal, let's see, 4 goes into both of these, 7 over 2. Or you could say 3.5. I'll leave it as 7 over 2. So that is the answer for k. I'll just spell out the other way I did it first of all. It is a bit longer. What I did is I differentiated fx here. I got the derivative of fx to be 4x plus 8. But I knew the slope, the derivative is the slope. I knew the slope I was looking for was actually 2. So I knew this was equal to 2. And I solved it for x. I believe x equals minus 3 over 2. That's where I realized there was a faster way. But what I would have done is I would have put this x into this equation here and got a value for y. I would have found out what y equals. The same y would work on this guy and the same x. So I would have put the y I found out equals the x I found out, and I would have solved for k. Wouldn't have been too much longer or more difficult. I just think this is a more elegant solution. Okay, let me rub this out and we'll start part 2. Right, part 2 says, in the case where k is minus 9, find the values of x for which fx is less than gx. So again, there's two ways to do this question. Let me just write out what k equals minus 9 looks like. We'll have fx being the same, plus 1, let me put in fx there. And we'll have gx looking like this, 2x minus 9. Do not get mistaken by that. That will change the answer immensely. In fact, it will make the question too easy if this was a minus 9, and the examiner probably will not give you any marks because it's too easy. So like I said, there's two ways to do this question. By far the easiest way is again to be able to draw it. So let's draw this again. Roughly this is this shape here. And we have 2x minus 9. Now how would I draw this? I'd go back to part 1. In part 1, gx was equal to 2x and k was 7 over 2. So that's minus 7 over 2. So let me put that one in here again. This is k. Well, let's forget about k. Let's call this because k was 7 over 2, whereas I'm more interested in minus k. Well, yeah, let's write minus k here equals minus 7 over 2. So the y-intercept. That's really what I'm interested in here. The y-intercept. In this case here, plus 9. Plus 9 is bigger than minus 7 over 2. So that means this line is moving up. So plus 9 is somewhere up here. And this is minus k is equal to plus 9. Or really, I could be saying the y-intercept here. The y-intercept is here. So I do know it hits it twice. I know the rough shape of everything in this question. Again, I knew this was a positive. So let me just draw that one more time a bit smoother. I know the shape of this question looks something like this. That's it's just known from my understanding of this being positive, my understanding of the slope here is 2, so I know it goes up, and my understanding that 9 is bigger than minus 7 over 2. Lets me know the shape looks like this. So let's ask ourselves then what the question asked us. Find values of our x where fx, this is fx here, is bigger than, is less than gx. So where is fx less than gx? Have I got them right? Yeah, I do. So fx here, this number is bigger than this number. So for that value of x, no, it's not right. Here, they're equal to each other. It's in here. It's if I put an x-axis down here, it's everywhere between these two numbers. That is what we're looking for. And really what we're looking for is what x is here. And let's write x1 and x2. Between these two x's. That's the answer to this question. So this has reduced the question down to just solving for these 2 points. The 2 points where they intersect. And as I think I pointed out in the first part, we've done that many times. And that is just 2x squared plus 8x plus 1 equals 2x plus 9. When do they equal each other? Well, when they equal each other. So that's all we have to do there. Let's put all this together. We get 2x squared plus 6x. I keep trying to write a minus there. And then minus 8 equals 0. I've just taken these away from both sides. Okay, when does this equal 0? If we divide everything by 2, that won't change anything. We'll get x squared plus 3x minus 4 equals 0. That can be factorized. That is x by x makes x squared. 4 by 1 makes a 4. And then 4 plus 4 minus 1, we'll get this plus 3 here. So what we have here is x is equal to 1 and x is equal minus 4. Well, minus 4 is smaller, so this must be minus 4 here, and this must be 1. So the answer to the question is x is bigger than minus, do they want bigger than or equal to? No, just bigger than, so bigger than minus 4 and less than 1. That is the full answer to this question. That is when fx is smaller than gx, in between these 2 points. Now I did promise there was another way to do it. Will I do it all out? I will do it all out. We don't have to draw a picture. Lots of students do not like drawing pictures. So if we have this question here, fx and gx, what they told us is, they told us fx, I realize it's harder to see over here, I'll try and write it big, 2x squared plus 8x plus 1 is less than 2x plus 9. Really, that's all they're asking us. So we can solve this without any pictures. It's just easier with a picture, to be honest. So to solve this, it's very similar. We'll get very similar things to here. We'll get down to something like this. X plus 4. Instead of an equals, though, we'll have less than 0. That still tells me something. This is 2 numbers. One number here and one number here. 2 numbers multiply to get less than 0. Well, that's only possible if one's a plus and one is a minus. But I don't know which, so I'm going to have to split this into 2 worlds. In one world, x minus 1 could be less than 0, and, it's very important it's an and, x plus 4 is greater than 0. Both of these things have to happen. This has to be less than 0, this has to be plus than 0 to get a minus. Or we could have x minus 1 being greater than 0 and x plus 4 being less than 0. Now I think that is definitely going to be too small for you. What I'm saying is x minus 1 is less than and this is greater than 0. That would make a minus. Or this being greater than and this being less than. That would also make a minus. Now let's try and solve these. We'd get x is less than 1, x is bigger than minus 4. That's the same answer we got here. Yeah, x is less than 1, x is bigger than minus 4. So we actually know this is the right answer already. The other possibility would have been x is bigger than 1 and x is less than minus 4. Now what's wrong with that? Lots of students leave this as answers when they get questions like this. Do not. Have a look at it closely. This is impossible because there was an and here. You could never be bigger than 1 and less than minus 4. It's impossible. This is a contradiction. We write a contradiction like that. Or you could simply just do this. The examiner will know what you mean. Just say that one's impossible. This is your answer. That would give you full marks again. Although I would like to write the answer out like this again. X is bigger than minus 4, less than 1. That's much more common, especially when we're dealing with an area like this. Okay, so that's part 2. It was pretty long, but I'll rub all this out and we'll get on to part 3. Okay, I got a bit carried away and rubbed out too much, but part 3 tells us that k is equal to minus 1, so it's a good opportunity to write gx again. Gx is equal to 2x minus minus 1 is plus 1. And they ask us to find, oh yeah, this is confusing, g minus 1 fx. So some people, depending on what country you're in, you might be more used to seeing a little circle in between these two. This is read inverse g of f. Bit confusing there. Maybe let me write that a bit bigger. In fact, let me do that one more time. G minus 1 O f x. Now they don't write the O. It means the same thing in their world. This does not mean the same as g inverse of g x multiplied by fx. That means a different thing. That's just the two equations multiplied together. No, this really means the same as this. That's a much more common way to write this, I think. But the exam wrote it without the brackets here. So this means is a function, whatever this function is, just put it inside this function. Now the first part of this question though really is, what is this function? The inverse of g. They're asking us to find the inverse of this function. So let me write this function out with a y instead of a gx. It's just a little easier to write. Y is equal to 2x plus 1. If I put an x in, I get y out. What they're asking is, what x did I need to put in to get y? Or really they want a function that if you put in the number that you know y to be. So for example here, if I put 1 in, I get 5 out. So let's see, x equals 1, y is equal, sorry, not 5, is equal to 3. They want a function that when I put 3 in, I'll get 1 out. And they want it to work every single time. So how do we do that? Really, it's as simple as just getting x on its own, rearranging this equation to get x on its own. I don't need these guys here. So let's rearrange this. I'll get y minus 1 is equal to 2x. So I'll get x is equal to y minus 1 over 2. I just switched sides there in the middle. Hope that didn't confuse you. Now, that means the number we put in here, this comes out. This is a new different function. Now you could go ahead and write this as g minus 1 of, I guess, y, I guess y is equal y minus 1 over 2. That would sort of be correct, because all we're saying is whatever number we put in here, we'll get this number out. We'll get this number out. But by convention, we always just use x's. We always use x's. That's why this x and y switch place. We just always use an x. But this is just telling me when I put y in, and I do this to y, I get this answer out. That's the opposite to what I did up here. Hope that was clear. I don't think it was, but another way to say it is you can just switch the x and y and then get y on its own. Let me do it that way just first. On this line here, if we just switch it, x equals 2y plus 1 and then get y on its own. A lot of students learn that way. We would get x minus 1 is equal to 2y. Let's switch the sides. Y is equal to x minus 1 over 2. Same thing though. So this is the inverse function. This is the inverse function of g. A lot harder to get the inverse function of f, by the way, but still possible. So let's try and do this question here. This becomes g minus 1 of fx, which is 2x squared plus 8x plus 1. Well, we know what the inverse of g is. Whatever's in this bracket goes into the x. So then this just becomes, let me just make that clear difference. This just becomes 2x squared, whatever's in the bracket, 8x plus 1 minus 1 divided by 2. So this isn't too hard to do. 1 minus 1 disappears. We get 2x squared plus 8x divided by 2. And that is just 2 goes into both of them. We just get x squared plus 4x. So that is this, I can't think of the word when you combine two functions, but that is this. Oh, and solve this equation for when it equals 0. So when does this equal 0? We'll get, let's factor x out. We take x out and we're left with x plus 4 equals 0. So what are the two possibilities there? X is equal to 0 or x plus 4 equals 0, which is x equals minus 4. There are the two answers here, this one and this one. X is either equal to 0 or x is equal to minus 4. So that solves that equation. Yeah, I think that's everything on that one. Let me rub this out again and we'll leave room for the last part. This is a long question. Each part is pretty much its own little question. Okay, part 4 only talks about fx, so I've just left fx up there. Express fx in the form of 2 multiplied by x plus a squared plus b. So this is a very common way to write a quadratic equation, but a lot of students do not learn it, unfortunately. Where a and b are constants, so these two guys are just constants, and hence then state the least value of fx. Okay, so first of all, let's just put it into this form here. Very common way to write a question. It's called completing the square. So if you didn't know the quadratic equation, or sorry, quadratic formula, this is how you would solve a quadratic every time, and it has its own uses. So completing the square, I guess I can't go into too much detail. I've already run a little too long, but let's see. What I need to do is get something that looks like this, x plus a squared. And let me just write over here. X plus a squared always looks like this. X squared plus 2 times ax plus a squared. So really, if I can find something that looks like this in here, I can take it out and turn it into this. That's what completing the square is. So let me look for something like that. First of all, let me get rid of this 2. And that's good because I wanted 2 out front anyway. I'll have x squared plus 4x plus a half. Now, does this look like this? Not quite, but let me change a few things and see if I can convince you it does look something like that. 2 times 2 times x plus a half. What about now? We have an x squared. We have 2 times a number times x. 2 times a number times x. So a is 2. Well, I'm hoping it is. The problem, 2 squared, a squared is 2 squared, is 4. There's no 4 here. If there was a 4 here, I'd be happy. So you know what I'm going to do? I'm just going to cheat. And I'm going to write 2 times x plus 4. Oh, but I'm not allowed to cheat. First of all, there's a half here. And if I add a 4 in, I better take it away again. Okay, now I haven't cheated anymore. But I've just cheated a little. I put a 4 in here. So really, I have exactly what this is. So I can write this again. 2x plus a squared. Instead of this guy here, this is just, sorry, not a. I don't need to write a anymore. X plus 2 squared. 2ax, 2x. A squared, 2 squared. And we're still left with 2 multiplied by a, well, what's this put together? Half minus 8 halves is minus 7 halves. 2 multiplied by minus 7 halves is minus 7. Let's see, I have too many brackets. Yes, that's it. And that's exactly what they asked us for, in the form of 2x plus a squared plus b. So in this case, a is equal to 2 and b is equal to minus 7. So don't get confused because there's not a plus there. If you want to put a plus there, that's okay with me. Plus minus 7 is the same thing. Alright, so that answers, no, not quite everything. Hence find the least value of fx. Just to remind you, fx looks something like this. So it does have a least value. It never goes below this line. There's a few ways to do it. If we do some calculus, some differentiation, we could do it. But we don't need to do that, all that work, because the answer is actually right here on this equation. That's one of the more useful powers of doing this way. What is the smallest number this can be here? Ask yourself that. Pause the video. You should be pausing all the time actually, but pause the video and ask yourself that. But the answer is 0. The smallest a squared number can become is 0. You can't get a minus when you square a number. So the smallest this guy can be is 0. 2 times 0 is 0. Minus 7 is the deciding factor here. The smallest number here is minus 7. That's the answer. I think the examiner would probably accept that, but I would say fx is greater than minus 7 is another answer, or just write it in English. The least value of fx is minus 7 is also a fine way to answer. Okay, that was a pretty long question. If you have any questions about any of the parts, please get back to me. I hope you noticed you didn't have to use differentiation for any of this. Part 1, I said you could use it. I tried to use it, but it was faster without it. Part 4 here, if they asked us just to get the least value, I'd say it's probably quicker to use differentiation. But they showed us that you didn't have to by making us do this way. And then once we did this way, it's very easy to find the minimum value. So this was a pre-calculus, I guess an American student would call it. We did not need calculus at all for this question. Alright, I hope you have a good day, and I'll see you next time.